Welcome back to another info index video. Today I will be teaching you about distributive property. Distributive property lets you expand expressions, and it is widely used in mathematics. It states that a bracket b plus c is equal to ab plus ac, where a, b, and c can be any expression. Let's do a few examples to see how this works. Here we want to expand x bracket x plus 5. Through distributive property, we know that this is equal to x times x plus x times 5, which can be written as x squared plus 5x. Here we want to expand 3x bracket 4y plus 5z. Through distributive property, we know that this is equal to 3x times 4y plus 3x times 5z, which is equal to 12xy plus 15xz. Now, what if there are more than two terms inside the brackets? For example, how would we expand a bracket b plus c plus d plus e? Well, it's simple. You just distribute the a to every term inside the brackets. This would be equal to ab plus ac plus ad plus ae. And this works for any number of terms inside the brackets. To apply this, we can expand this expression, 3x squared bracket 4x plus 5y plus 6z. This is going to be equal to 3x squared times 4x plus 3x squared times 5y plus 3x squared times 6z. This is equal to 12x cubed plus 15x squared y plus 18x squared z. Now what happens if we have multiple terms inside multiple brackets? Look at this example, a plus b times c plus d. If we treat a plus b as the term outside of the brackets, then we can use distributive property here. Then this becomes a plus b times c plus a plus b times d. And we can use distributive property again here. So this becomes ac plus bc plus ad plus bd. And I'm going to rearrange this so that it becomes ac plus ad plus bc plus bd. You'll see why in a moment. Now let's expand this example. A plus b plus c times d plus e plus f. If we treat a plus b plus c as the term outside of the brackets, then we can use distributive property to find the result. Now this is what it looks like after you apply distributive property once. You see that we have distributed the a plus b plus c term to every term inside the brackets, d, e, and f. We can actually apply distributive property again. Here we distribute the d to all of the terms inside the brackets, a, b, and c. This becomes ad plus bd plus cd. We do the exact same thing here and here, which gives us ae plus be plus ce plus af plus bf plus cf. So I just went ahead and rearranged all of these terms here so that they become ad plus ae plus af plus bd plus be plus bf plus cd plus ce plus cf. Now when we look at these two examples, we can see a pattern. When we are multiplying two expressions together, we can distribute the first term of the first expression with all of the terms in the second expression, plus the second term of the first expression distributed with all of these terms, all the way to the last term of the first expression distributed with all of these terms. And this will work with any number of terms in either expression. Here's a general formula for multiplying binomials of the form a plus b times c plus d. But remember that this formula also works for any number of terms. Here we want to expand 3x plus 4y plus 5z plus 6w times 4 minus x. First we distribute the 3x with the 4 minus x. So we have 3x times 4 plus 3x times negative x. Then we have to distribute the 4y, so we add 4y times 4 plus 4y times negative x. Then we distribute the 5z here, so that we add 5z times 4 plus 5z times negative x. Finally, we distribute the 6w. So this is 6w times 4 plus 6w times negative x. Now all we need to do is simplify this line. So this becomes 12x minus 3x squared plus 16y minus 4xy plus 20z minus 5xz plus 24w minus 6xw. And that is how you deal with multiple terms inside two pairs of brackets. We simply take the first term here and distribute it with all of the terms in the second pair of brackets. Then we distribute the second term here with all of the terms here. And you repeat this for every term inside the first pair of brackets. Now what happens if we have a plus b squared? Can we just distribute the exponent so it becomes a squared plus b squared? Let's find out. So we can rewrite a plus b squared into a plus b times itself. And we know from distributive property that this is equal to a times a plus a times b plus b times a plus b times b, which can be rewritten into a squared plus 2ab plus b squared. And as we can see, this is not equal to a squared plus b squared. Now let's expand a plus b times a minus b. From distributive property, we know that this is equal to a times a plus a times negative b plus b times a plus b times negative b. We can rewrite this as a squared minus ab plus ab minus b squared. These two ab terms cancel out, and we're left with a squared minus b squared. So here are the two formulas. A plus b squared is equal to a squared plus 2ab plus b squared. And a plus b times a minus b is equal to a squared minus b squared. The second formula is called a difference of squares. Remember that a and b can be any expression, such as x, y, or 3xy squared. Now let's do some examples. Here we want to expand 3x plus 6y squared. We know from the formula that this is equal to 3x squared plus 2 times 3x times 6y plus 6y squared. This is going to be equal to 3 squared x squared plus 2 times 3 times 6, which is 36xy plus 6 squared y squared. We can write this as 9x squared plus 36xy plus 36y squared. And that's it. Next, we want to expand 9x plus 4y times 9x minus 4y. We know that this will expand into a difference of squares, as it is of the form a plus b times a minus b. Therefore, it is just equal to 9x squared minus 4y squared, which is simply just 9 squared x squared minus 4 squared y squared, which is equal to 81 x squared minus 16 y squared. Now let's use these formulas to factor the following expressions. Here we want to factor x squared plus 4x plus 4. We wish to write it in the form a squared plus 2ab plus b squared. In the first term we have x squared. This can remain the same. Next we have the 4x term. Can we write it in the form 2 times a times b? We can. It is equal to 2 times x. And in the next term we have 4. This is equal to 2 squared. Now as you can see, we can factor this into x plus 2 squared, which is equal to x squared plus 2 times x times 2 plus 2 squared, which is exactly what we have here. If you're confused about how I got this, you can watch our previous video on factoring. Now let's factor 9x squared minus 36. It appears to be a difference of squares. 9x squared is really just 3x squared, and 36 is equal to 6 squared. Now we just use the difference of squares formula, and this is equal to 3x minus 6 times 3x plus 6. As we can see, here we have a common factor of 3, so we can just factor that out. 3 times x minus 2, and here we also have another common factor of 3. So let's just factor that out, 3x plus 2, and we can multiply the 3's together, so this becomes 9 times x minus 2, x plus 2. Here is what we've learned in this video. The first equation is a distributive property. It tells us that the term outside of the brackets should be distributed with every term inside the brackets. The second equation tells us that this formula works for any number of terms inside the brackets. And the third equation tells us how to multiply two binomials together. It is simply an application of the first equation. The fourth equation tells us how to properly expand the square of a binomial. The exponent is not distributed to the a and b terms. And the fifth equation tells us how to factor a difference of squares. Anyway, this was the info index lesson on distributive property. Don't forget to leave a like and subscribe for more content.